This is Tihasni from CSCC. Today our topic is about nested functions, functions with pass. Okay, introduction. Let's look at some examples of the benefits of nested Python functions and how to use them to encapsulate code, closures and decorators. Here, nested or inner nested functions are functions that we define inside other functions to directly access the variables and names defined in the enclosing function. Yes, as we all know that nested functions have many uses, primarily for creating closures and decorators. Yes, in this topic we will gonna learn about how to provide encapsulation and hide your functions from external access, and how to write helper functions to facilitate code reuse, and create closure factory functions that retain state between calls. And lastly, code decorator functions to add behavior to existing functions. Yes, now here I'm going to say about creating nested functions in Python. So how to create a nested function in Python. Now let's work out with an example by using a nested function. As we see in the example, def outer function, and we have given inner function. Now we have printed hello world. And here if we see in the output, the output will be hello world. In this code, we will be defined internally to display a string. To do this, we call on the last line. Here, the inner function and outer function and the hello world and the inner function and outer function, the major use of internal functions in their easiness to access variables and objects from an subscribe, which is called external function. The enclosing function provides a namespace available to the nested function. So, I think we have gotten overview how to create a nested function in Python. And another example of a more complex nested function. As we see in the in the program, here we have given the number and we have written the number must be whole, the number must be non-negative, and we have written the code. So if we come into the output, the output is 24. How we got 24? In the function, we first validate the input to make sure the user is providing a non-negative integer. We then define a recursive name inner function that computes the factorial. In the last step, the corresponding calculation is called and performed. Here, the main topics are factorial, inner factorial, and the another inner factorial. Now, the main advantage of using such a pattern is that by doing all the arguments check in the outer function, we can safely skip the error checking in the inner function and focus on the current computation. Now, the basics of using nested function in Python. What are the basic of using nested function in Python? So, what is the use of Python? So, firstly, I have said in the introduction, encapsulation. What is encapsulation? A common use case for internal function is when you need to protect or hide a function from everything that happens outside of it. That is, completely hide the function from the global space. Encapsulation is nothing but completely hide the function from the global scale. So this behavior is called as encapsulation. Now for that also we have an example. The example is we have given the def increment number and we have given the code. Now let us see in the output. The output will be, let's call the nested function inner increment. Yes, name error, name inner increment is not defined. Yes, in this example we don't have direct access to. Next, by bringing to access the nested function, we get the function hides the function completely, so preventing access from the global space. So I think we have understand what is meant by encapsulation. Now, scope of variable in nested functions. The location where we can find a variable and a function, if it is required, is called a scope of a variable. So scope of variable is nothing but the location where we can find a variable in the nested function. So now how to access a global variable inside a function? But what about accessing the variable of an outer function? So for this also we got an example. That is, we have given function f1, we have declared function f1, and for that we have given s is equal to, so whatever we can keep s or whatever. So we given I love Python, and also we declared function 2. For that also have given me too. We need to print s. Coming to the output, I love Python. We got the output I love Python. So for the brief explanation, in the above example, it can be seen that it is similar to accessing the global variable from a function.
I am Vaishnavi. Now I'm gonna continue the next topic. Now let us suppose you want to change the variable of the outer function. Let us see another program. First, declare the function f1 and give s is equals to I love Python. Next, declare the function f2 and s is equals to me too. Now we're gonna print s f2. So output is me too and I love Python. It can be seen out the value of the variable of the outer function is not changed. However, the value of the variable of the outer function can be changed. So next topic is different ways to change variable value of the variable. Using it, we have two types, using iterable function and using non-local keyword. First, let us look at into iterable function. First, declare f1 and s is equals to I love Python, and declare s2, s is equals to me too, print s. So the driver code will be output me too. Next, using the non-local keyword, first declare f1, s is equals to I love geeks for geeks, and declare f2 non-local s is equals to me too. Print s. Driver code, and the output will be me too. Python closure. A closure is a function object that remembers values in enclosing scopes even if they are not present in the memory. It is record that stores a function together with an environment, a mapping associate each free variable of the function. Variables that are used locally but defined in an enclosing scope, with values or references to which the name was bound when the closure was created. A closure, unlike a plain function, allows the function to access those captured variables through the closure copies of their values or references, even when the function is invoking outside their scope. Filter none. Let us see an example. First, define the outer function text. Text is equals to text. Next, define the inner function print function. Next, print text. Return inner function. If name is equals to main, my function is equals to outer function hey. My function. Output hey. As observed from the above code, closures helps to invoke function from outside the scope. The inner function has its scope only inside the outer function. But with the use of closures, we can easily extend its scope to invoke function outside its scope. Next topic is changing behavior with nested functions, decorators. Python decorators are the next popular and easier to use cases for internal functions, especially for closures. Decorators are high order functions that take callable object functions method class as an argument and return another callable object. Typically, decorators are used to dynamically add properties to an existing called and transparently extended its behavior without affecting or modifying the call. A decorator function can be applied to any callable object. To do this, the symbol and name of the decorator are placed in the line preceding it at the decorator. Syntax is def decorated function body pass. This above syntax forces you to automatically accept it as an argument and process it in your body. This operation is an abbreviative for a statement like this: decorator function. Decorator function is equals to decorator of decorated function. And he is an example of how you can create a decorator function to change the behavior of an existing function. Let us take an example. First declare add messages and add messages function and add messages. Print this is my first decorator function. Print by and then return add messages at the rate add messages. Def next declare greet, print hello world, greet. The output will be hello world. In this example, we use functions to decorate. As a result, the function gains new functionality. Now when we call, instead of just typing, it prints out two additional messages and at the rate messages greet hello world.
This is Santoshi. Now I am talking about Python pass statement. In Python programming, the pass statement is a null statement which can be used as placeholder for future code. Suppose we have a loop or a function that is not implemented yet, but we want to implement it in the future. In such cases, we can use the pass statement. The syntax of the pass statement is pass. Using pass with conditional statement. Now let's take a number 10 and later hash use pass inside statement. Let's take if statement. If n greater than 10, pass print hello. Here notice that we have used the pass statement inside the if statement. However, nothing happens when pass is executed. Pass is executed. It results in no operation. Suppose we didn't use pass and just put a comment as, let's take number 10, if n greater than 10, write code later, print hello. Here we will get an error message, indentation error, expected and indented block. Note, the difference between a comment and a pass statement in Python is that while the interpreter ignores a comment entirely, pass is not ignored. Use of pass statement inside the function of a class. We can do the same thing in an empty function or class as well. For example, declare a function pass, class example pass. Conclusion. So in the Python, nested functions have directly access to the variables and names the you define in the enclosing function. It provides a mechanism for encapsulating functions, creating helpers, solutions, and implementing closures and decorators. In this case, when the condition is true, the pass statement is encountered and no code is executed. However, when the condition is false, the code inside the else block is executed. The pass statement is useful in situations where you want to create a structure or define a block of code without writing its implementation immediately. It allows you to write syntactically correct code that can be explained out. This course activity is presented by T. Hasni, T. Vaishnavi, S. J. Lakshmi Devi. Thank you.